can you explain to me what is your innovation doing on the behind the technology and basically how this deep tech side of it?
Something which is used in labs since 40 years, but we make it possible to use it in the field in real time.
You would say it's less than 1% of error when doing the analysis state of charge and state of health of batteries. How is it so accurate?
Most of the time when we talk about state of health, we are talking about a capacity. And let's say, okay, my battery is at 90% capacity. The point is, most of the time, if you just read from the BMS on a car, this 90% is not accurate. You need to understand how do you lose this 10%? Because sometimes one battery at 90% can last 10 years and one other at 90% 1 month. Because the type of degradation is dangerous.
Hello, Gaëtan. Thanks for joining us in Scouted by GreyB. Is there something exciting happening in Entroview? Something interesting that recently happened?
Yes, actually, we have a great news because after 3 years and a half since our creation, we are launching our first product, which is a solution, hardware plus software, to diagnose batteries out of electric vehicle cars because we want to initiate the repair market of electric vehicles. Right now, it's not really done because it's too difficult to do a proper diagnosis on electrical batteries. And we are launching this product to solve this problem. And so that's a great news for us. We are a deep tech company, so we came from research on thermodynamics of batteries. We had a lot to coming from lab to get it to the field. It takes a lot of time, but we have this first application, and we're quite happy and quite excited about that.
And you've invested a lot of time. So congratulations on the launch. Gaëtan, can you, in short, can you explain to me, what is your innovation doing behind basically on the behind the technology and basically how this deep tech side of it?
There are a lot of innovation in the battery fields, but still we're using old technology of batteries. The battery we have in your cars, in your laptop, in your smartphone, most of the technology was invented 40 years ago. But still, we're not able to do proper diagnosis in real time of those batteries. That's why we have sometimes sudden fire, sudden death of battery, or sometimes the state of charge is not correct. What we bring to the market is, let's say, lab-grade diagnosis, something which is used in labs since 40 years, but we make it possible to use it in the field in real time. That came from the PhD that my partner, Sohaib Al-Uthmani, did in Singapore and France with one of the inventors of the lithium batteries, the guy who invented the anode 40 years ago in France. They worked on the algorithm and the patent and algorithm to be able to calculate in real time entropy of battery. The entropy is a physical understanding of what is happening inside a battery during a charge or discharge. It's based on thermodynamics, as I mentioned, on temperature. And with that, we can spot the phase transition occurring during a charge or a discharge. When the lithium atoms are intercalating in one electrode, we have some phase transition. Yeah, you probably know the phase transition between liquid and solid. Here it's a solid-solid phase transition. It's known since decades that having a good insight of the phase transition is a good way to diagnose batteries. What we bring is the ability to do that with the existing sensor in real time. So we have a lot of application based on that. We started by working with gigafactories in Europe to help them improve their safety test at the end of line. So we use those research, and we put them on the field. But right now, for later stage, for the after sales market, when the battery has a problem, you want to be able to repair it. So we use those research to be able to offer a more accurate diagnosis than everything that exists.
So why entropy-based analysis only?
Well, we're not only based on that, but what is new is the fact that we bring physics into this subject. We need to have people from physics, electrochemist people, data science people, and you need to bring them together to create something new. And the physical approach is really rich because we are in a time where we are talking a lot about machine learning and artificial intelligence. But if you have called advanced physical data, you can get way more with those data than if you have kilobytes of data. So the goal is to combine these different worlds to have something more meaningful. It's also because it's difficult to have good data from the field for different reasons. So with our solution, we need less data to get further. To combine physics and machine learning is really powerful.
And you mentioned that this way of measuring or analyzing the battery health, it's way more accurate than anything else on the market. You say it's less than 1% of error when doing the analysis on state of the state of charge and state of health of
Yeah,
batteries. So can you tell me a little bit about how is it so accurate compared to other methods?
we bring different things on the table. For the state of health, most of the time when we talk about state of health, we are talking about a capacity. And let's say, okay, my battery is at 90% of capacity since the factory. The point is, most of the time, if you just read from the BMS on a car, this 90% is not accurate for different reasons. So we need to be more accurate. But even if we get more accurate, and we are with less than 1% of error, you need to understand how do you lose this 10%, because sometimes one battery at 90% can last 10 years and one other at 90% 1 month, because the type of degradation is dangerous. We have this correct state of health based on entropy, but also with the same technology we can say, okay, the 10% you have lost it with growth of SEI or with lithium plating, or and to have this explanation of the degradation mode allow us to be really more confident about the future of the battery. For the state of charge, it's roughly the same technology. We use the fast transition to spot where the real state of charge is. For LFP batteries, which are growing bigger and bigger in the automotive industry, and where it's difficult to have a correct state of charge over time.
Basically, how is Entroview system able to maintain this accuracy when there's so much chaos going on inside the battery?
As we're working with battery producer, cell producer, we know that every cell is different. There's no such thing as two exact cell. But still, we can define a typical fingerprint of a cell from production, and we can spot the deviation, meaning that we will have some minor deviation in every cell. But what is interesting is it a problem for safety? Is it a problem for power? Or it's just okay minor deviation without no problem in the future. So that's what we're doing with physics, and that's also why we need to combine with machine learning. With physics we can say, okay, we've seen this type of degradation, and machine learning help us to be more robust, but also to be able to quantify this amount of degradation. So it's really a combination of those two worlds, data science, physics, that can allow us to be more precise and accurate.
I also wanted to know that in this industry, in battery industry, OEMs and basically the BMS systems, they are like very rigid and they are usually not that adaptable. So what I want to understand is basically what is Entroview's strategy to expand, and basically are you planning to be part of BMS system? Are you partnering with them, or is basically are you going to be as an additional layer of testing?
We are testing battery out of the car because it's easier. But of
Hmm.
course, we want to be embedded in a car to that we believe that actual batteries can last. Actually, now the lasting average 10 years. We believe that the same battery could last 15 years with proper diagnosis and monitoring. We have some POC running with major OEMs to be able to be embedded in the BMS. Another option that we are looking at is to add, beside the BMS, a small microcontroller, small
Hmm.
chip, to do the analysis. What is interesting is the core of our technology is algorithm. They are really light, so they can be embedded in a BMS or any microcontroller. To do the more in-depth analysis, we will need to get to the cloud to have more power. But what is interesting is we will need few data. It is based on physics. We don't need large amount of data. So
Hmm.
we solve also the problem of transferring continuously large amount of data, which
Hmm.
is a problem for security. With our technology, we need a few data because some calculations are done on the car. We need the result of those calculations, and with that, we can do our more in-depth analysis on the cloud.
And I understand your system also considers battery temperature in the analysis. So does it also require some additional sensors to be placed, or is it like totally independent of those things?
But what we are seeing right now, working with OEMs or others, is with the actual sensor, we can bring a lot on the table. We use the sensor existing, which are most of the time really good.
Hmm.
So that's not a problem.
So can Entroview system or the data that you analyze, can it work as, as a feedback loop into maybe, you know, helping OEMs make more adaptive charging solutions or more basically predictive maintenance type of suggestions? So is it working like that as well?
You can adapt the charge for these batteries, meaning sometimes you will accelerate the charge at certain state of charge, and at others you will lower it down. And
Hmm.
if you're able to do that, and you're able to adapt to every batteries, you can extend again the lifetime of the batteries. And also, if you want to keep the battery longer, you need to be able to do predictive maintenance. You need to also do warranty extension, and
Hmm.
with our data, we will be able to do all of that.
This is great to hear. So in future, basically my car can have your system implemented, and it
Yeah,
can basically just having a small microcontroller installed can increase my battery life from 10 to 15 years. This is going to be like a dream of many car owners. You mentioned you're testing a lot of testing your product with gigafactories. So in factories, productions are very fast, and they're like within seconds they're making a lot of products. So, and I know current testing, based on your website, what I know is current testing models, they take around 10 days, sometimes 8, and you are able to bring it down to 2 days. But
yeah.
in case of factory settings where every second a battery is being produced, so how does this inline testing work in that sense? Basic interviews
Yeah, but even for factories which are producing with high speed, they still need some time to do those tests at the end of line. So, and those it's not 10 days of test. Roughly, you are storing them at a certain temperature, and you every days or 2 days, 3 days, you spot how they evolve. The goal is to do that quicker, but it
Mm.
is done in every factory in the world. Yeah, right now we're more focused on the car industry because what I said, we were working in Europe, and the market for gigafactories in Europe is not so good.
Mm.
So we switched to the OEM side. Maybe at one point we will get back to working with gigafactories at a more larger scale, but as a startup, we need to focus.
What's the current challenge that interview is facing, or maybe interview is about to solve in terms of scaling?
With our first products, we want to unlock the repair market, but what we want to do next year is to unlock the second-hand market because when you buy a used electric vehicle, you want to be sure of the battery. But for this year, what is interesting and what is challenging is this market does not really exist because there is no real battery repair market.
Mm.
And we believe that with a proper diagnosis, we could solve that, but it means that we will need to create the offer and the demand at the same time because okay now you have a new battery that have been diagnosed and certified, but
Mm.
we need to get people to do the repair because nobody is doing that really right now. So that's challenging to create both sides of the market at the same time. In the same time, we are seeing a lot of appetite for that because well, we more and more have electric vehicles that need to be repaired. We can bring a lot of value on this market. In Europe, we and in the US, we need to wait a few years to have a big
Yeah.
second-hand market because the sales 5 years ago were really small, but it's coming.
Yeah, no doubt. Actually, recycling facilities or reusable side of things kicks in terms of batteries when they're no longer suited for cars, but they can be reused somewhere else, or maybe when they need to be recycled properly. So, have you done any testing in those areas? Real world dismantling workflows or any kind of those?
Yeah, with the diagnosis, we can say, okay, this is proper for getting back to a car. This is not proper anymore for automotive purpose, but you can use it on second life application, and
Hmm.
we can even add a warranty on that. Or you have to send it to recycling, and for recyclers, they need as much information as possible because they will not use the same way LFP and NMC
Hmm.
or even the percentage of raw material in it, how much nickel you have in it. And with our physics-based analysis, we can provide those type of information, and it helps to get the battery to the right place. And also with a proper diagnosis, you have no problem for transport If you don't have a good diagnosis, you don't know if you can transport safely or not. We will help to solve all those problems.
But there's just one more thing I wanted to ask you. Your early ventures were related to fintech, and then you have like very diverse experience in terms basically as an entrepreneur as well as a technology enthusiast as well. So basically, how did this transition happen that you entered into battery tech?
I'm an entrepreneur since more than 20 years
Yeah.
right now. I want to commit my professional career to the fights against climate change. And I've done several things, but I get to the deep tech startup. I believe with technology, not that that technology would solve everything, but we can maybe change the problem and find a easier solution. I want to do that as an entrepreneur.
Yeah, definitely. How do you, or I would say, you must feel like any founder that maybe this is not going to work, or maybe this is going to be difficult. So, what is your way of dealing with such thought, and how do you keep pursuing it?
What is important is the journey, not the goal. We can learn as a company, as people, we can learn a lot, make people inside the company grow also, create value for our supplier, investors, etc., and make the ecosystem better at the end of the process, even if the company is not successful. If you made a lot of progress, other companies can work on what you've done. People inside your company may create other companies. I may create another one. So you just have to do the job the best way you can, hire the best people, try to emulate ourselves and create something great.
That these are like really great words. All the points you mentioned, specifically having great people and just believing in that maybe even if it doesn't work, everybody will get something out of it.
Yeah.
So that is a really nice thought. And with that, Gaten, I think that's the end of our interview. Thanks for sharing in such detail about what Entroview is doing in this technology.
Thank you very much. My pleasure.